Alright, this video is about finding the area of a circle, and we'll look a little bit at how one way to derive or come up with the formula for the area of the circle, and then we'll show some examples of how you can use that formula to find out some information. So first we need to quick recap some of the parts of the circle, what we're talking about. So we've got a circle drawn here. If we draw a line from the center of the circle out to the outside, you got to remember that that is called the radius. Okay. If we carried that line all the way across, okay, through the center of the circle as well, we then have the diameter. So we recognize that the radius is half as long as the diameter, or in other words, the diameter is 2 times as long as the radius. Okay, and the other one that we discussed in our last video was the distance all the way around the circle is called the circumference. Okay, so today we are going to look at the area of a circle. So the area of a shape simply is all of the inside. Okay, so you could think of if you were going to fill the space, if you had a circle drawn on the ground and you needed to fill the space or cover the space, how much material would it take to cover that space? And so there is a special relationship for that. And the way that we're going to show that looks at the area of a parallelogram that we would have discussed at a different time. So I'll show you in the next slide. Alright, so suppose we have a circle, okay, and if we have this circle and we divide it nicely into 8 pieces, okay, so we've got a nice pizza going on here. Okay, we've got 8 pieces to the pizza. Okay, remember from the last slide that the distance around the circle is called the circumference. Now, instead of just drawing the circumference out, I'm going to split the circumference into 2 different colors, and you'll see why later. So that half of the circumference is blue, and then we've got the rest of the circumference is red. Okay. So just to clarify, or to show that even more, I'm going to color in, so now I'm representing the area, I'm going to color in the bottom half of the pizza red and the top half of the pizza blue. Okay, now the pizza, you can see the pizza slicer did a nice job cutting it up into 8 pieces, and people are going to start digging in, but they're not going to eat it. They're instead going to change the shape of the pizza and make a little design out of it. So we are going to try to do that. So the 4 blue pieces are going to be laid out beside each other like this. Okay, and then the 4 red pieces are going to be laid out beside each other like this. Okay, and you might be thinking, why in the world would you lay your pizza like that? But for this example, hopefully it helps us kind of see what's going on. Okay, so we've got the same area of pizza, right? We've taken those same slices of pizza and just laid them in a different way. Now, this is where we need to pay close attention. Remember that the formula for the circumference of a circle is equal to pi times the diameter. Okay, now, if we look at this distance here, it is very close to the distance that would be half of that diameter, right? If we look at from there, right, and we follow, that's 4 pieces of pizza there, which is halfway around the circle. So what would half of the circumference be? Half of the circumference would simply be pi times d, divided by 2. So this length here should be pi times d divided by 2. Wait a minute, d divided by 2, that sounds awfully familiar, or it should sound awfully familiar. Remember, we had another relationship. Diameter is equal to 2 times the radius, right? If we wanted radius on its own, we could divide both sides by 2, and there we have it. Radius is equal to d over 2. Okay? Are you following? So this means that instead of writing pi times d over 2, we could actually write pi times r. Okay? So this length here, is pi times r. Okay, now this length up here then must also be pi times r. Okay, because it's just the other half of the pizza laid out there. So that one is also pi times r. Now we're also interested in this distance right here, the height of this shape. Okay? The height of that shape, well, that's very simple. This is the middle of a pizza piece. This is the edge of the circle. The distance from the middle to the edge is r, right? So the height is very simply r. Now, when we've laid the pizza out like this, you may have noticed that it looks awfully similar to the shape known as a parallelogram. Okay, and hopefully you recall that the area for a parallelogram is the base times the height. Okay, so therefore the area of the parallelogram is base times height, and we've just drawn out kind of a little lopsided parallelogram that has the dimensions of pi times r as the base of the parallelogram and r as the height of the parallelogram. We could write an equation for the overall area of this pizza parallelogram. Okay? So we would plug in, if the formula is base times height, we're going to plug in what we know. Area is equal to base, which is pi times r, and the height, which is another r. When we do that, r times r we can simplify to be r squared, and r squared times pi, or more conventionally we go pi r squared is equal to area. And there you have it. That is the formula that tells us how to find the area of a circle. Okay, so that's one way that we can kind of prove what the formula is. Okay, some of you will be interested in that. Some of you maybe just want to know how to use the formula. So we'll do a couple examples how to use the formula on the next slide. Okay, so we've got an example. We have a circle that has a radius of, let's have this radius be 46 millimeters. My pen's a little too big to write this clearly. Okay, radius is 46 millimeters, and we are asked to find what the area is. Okay, so that's easy because we have a formula. Area is equal to pi r squared. Always get in the habit of actually writing out the formula to start it. It just makes you more aware of what's going on, and makes it easier for the teacher to follow what you're doing on your homework assignments and your tests, but also it'll prevent you from making some common mistakes. So start with the formula. Area is equal to pi, and then we need to figure out what r squared is. R, we know from the diagram above, 46 millimeters. So 46 millimeters squared actually just means 46 millimeters times 46 millimeters, right? Yeah, so I can't do that in my head, so I'm going to do it quickly over here. 46 times 46. Okay, so we've got 36, 24, 27. Cross that out, we're done with that. Add a 0. 24, it's going to be 16, 18, and then we add up these two columns. So we've got 6, and we've got 11, another 11, and 2. Okay, so 2,116. Okay, so therefore area is equal to 2,116 times pi, and the units for that would be millimeters, and notice we multiplied millimeters times millimeters, which is millimeters squared. Now some of you might be not like having that pi there, so we can multiply that in as well. The rounded version of pi that we use is 3.14, so we'll do that here, 3.14. And getting lots of practice here with our multiplication. Okay, so oops, I'm going to make a mistake there. I'm going to clean that up a little bit here. Sorry about that. Okay, 4 times 1 is 4, plus 2 is 6, and 4 and 8. Okay, next place is 6 and 1, 1 and 2, and finally got 18, and 3 plus 1 is 4, 3 times 1 is 3, and 6, and we're going to add all of that up. We've got 4, 12, 4 plus 2, 6 plus 8 is 14, 10, another 14, and 6 and 6, and we recognize we've got our 2 decimal places, which means we put the decimal in right there. So it is, the overall area is 6,644.24 millimeters squared. So 6,644.24 millimeters squared would be the area. Okay, and we'll do one more example. Okay, this example gives us what the area is, and we are going to try to determine what the radius is of the diameter. Actually, we're going to make it even a little bit more complicated. We're going to be asked for what the diameter is. Okay? So the area of a circle, we're going to say, is 48 centimeters squared. Okay, and we were asked for the diameter. So we don't have a formula that directly relates area and diameter, but we do have one that goes area to radius, and then we can remember that diameter is equal to 2 times r, and we can solve for the radius at the diameter at the end. So we'll start with our area formula, pi r squared. So we are trying to isolate this for what the radius is. So the radius right now is being multiplied by pi, so we want to get rid of that pi. We divide by pi. If we do that to one side, we must do that to the other side as well. So we now have r squared is equal to area over pi. Okay, and we want just r, so we take the square root of that. That means we need to take the square root of that as well. R is equal to the square root of area divided by pi. Okay, now we can plug in what we know. So the square root of area was 48 centimeters squared. Okay, and we're dividing that by pi. Okay, and that's going to give us what the radius is. Okay, so some of this math is maybe getting a little more complicated. So since these numbers are maybe not ones that you can do in your head quick, and for the sake of time on the video, I'll just quick punch them into a calculator, and when we do that, we find that r is equal to the square root of 15.3 about. And then when we take that square root, actually r is equal to about 3.9. and that's in centimeters. So then remember the question asked us for the diameter, so you both go back up here and we plug that in. 2 times 3.9 centimeters works out to 7.8 centimeters for the diameter. Okay, so hopefully that is helpful.
Made with Doodlecast Pro.